Emergency response training is rarely discussed in environmental terms, and for good reason. Safety, readiness, and compliance must always come first. But as organizations across aviation and energy and critical infrastructure take a closer look at their operational footprint, training methods deserve the same scrutiny as any other activity. The question is not whether virtual simulation has an environmental impact. It does. The real question is whether it replaces activities with significantly higher impact. In most cases, it does. The environmental footprint of emergency response training is driven far less by classrooms or materials and far more by logistics. Traditional training models depend on moving people, equipment, and instructors to a location, often repeatedly, to maintain readiness. That movement carries the highest cost. Air and ground travel for trainees and instructors, accommodation and subsistence, transport of specialist equipment, operation of training facilities, repeated setup, and teardown cycles. These elements dominate the footprint because they must be repeated, and because they involve physical movement, often over long distances. Travel is the primary driver. A conservative example illustrates this clearly. 20 trainees attending an in-person session, traveling short haul with one instructor and 1 or 2 nights of accommodation. A short-haul return flight typically produces around 200 to 300 kilograms of carbon dioxide equivalent per person. Even at the low end, that results in roughly 5 tons of carbon dioxide equivalent for a single training session. When sessions like this are repeated multiple times per year, as they often are, emissions scale quickly into the tens of tons annually. This single factor outweighs nearly every other component of the training footprint. Beyond trainees, there is also the movement of instructors and equipment. Vehicles, rigs, pumps, or specialist assets must be transported, set up, and dismantled. Fuel is consumed. Emissions are generated. Operational cost increases. These impacts are rarely itemized in sustainability reporting, but they are well understood by anyone involved in training delivery. Virtual simulation changes this structurally. Instructors operate from fixed locations. Equipment does not move. Scenarios are deployed digitally. The benefit here is not marginal, it is built into the model. Physical drills and live substitutes introduces additional impact. Generators, pumps, water usage, consumables, and cleanup operations all carry environmental cost. Virtual simulation does not replace physical drills entirely, nor should it, but it reduces the frequency with which physical substitutes are required simply to maintain familiarity. Reducing frequency matters. There are also smaller cumulative factors. Printed manuals, handouts, and sign-off documentation present a modest but ongoing material and emissions cost. Digitization reduces this overhead while improving version control. Lighting, HVAC, IT systems often running below full utilization. Virtual training shifts energy use into environments that already exist, adding marginal load rather than powering dedicated spaces. This is an efficiency gain, not a claim of zero impact. Virtual simulation does introduce its own environmental cost, cloud computing, network traffic, and user devices. Even when estimated conservatively, these impacts are small. For example, 2,000 hours of simulation per year might consume around 500 to 600 kilowatt hours of electricity. This equates to roughly 100 to 150 kilograms of CO2 equivalent annually. This is a fraction of the emissions from a single avoided in-person training event. Being explicit about this comparison matters. Virtual simulation is not a sustainability gesture. It does not eliminate impact. It replaces high-impact, low-efficiency activities with lower-impact, high-efficiency ones. The benefit comes primarily from reduced travel, reduced physical movement, and reduced reliance on dedicated facilities. Everything else is incremental but cumulative. For emergency response, this distinction is critical. Training cannot be reduced in the name of environmental goals. Readiness must come first. Virtual simulation allows organizations to train more frequently, reduce logistical overhead, maintain realism, and lower the environmental cost per training hour. That combination is difficult to achieve through traditional methods alone. The environmental impact of emergency response training is driven less by what happens on screens and far more by what happens on roads and runways. Virtual simulation changes that balance, not by claiming zero impact, but by removing the most carbon-intensive elements of training by design. If you'd like to discuss on how you can make your emergency response training more cost-effective and environmentally friendly, email us at info@structurist.com. Thanks for watching, make sure to subscribe, and if you'd like to see more videos like this, like the video.